Hi, welcome to our pre-calculus. Topic today is sum and difference identities, problem type 3. The type here refers to the situation where information about two angles are given through their trig functions and their quadrants, and we want to find a trig function of their sum or difference. Here let's take a look at several examples. So first one is asking for tangent of a minus b, or alpha minus beta, and for sine of alpha we know that the value is 513 and alpha itself is in quadrant 2. Beta, sine of it is given and we know that beta is in quadrant 4. We want to find the exact value of the tangent of difference. Well, several ingredients are required here, and you want to essentially review some of similar problems that we had before. So first of all, tangent of alpha minus beta. You remember we had the following formula for it: tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent of beta. So to find tangent of alpha minus beta, it's best to find tangent of individual angles. So what do we know? We know that sine of alpha is 513 and alpha is in quadrant 2. So best is to look at this situation in coordinate system. So we have some alpha in quadrant 2. This is alpha. Suppose there is some point here, coordinate on that is x and y. So that means this is our y and this is our x, and this is the radius r. What we want is to find tangent of alpha so that we can use it here. Well, we know that sine is 513, and what is the sine? Sine is a ratio, so let's denote it on our picture. Ratio of opposite to hypotenuse. The easiest thing to take is opposite 5, hypotenuse 13, and let's go ahead and find the other leg. So what's that going to be? Well, we know that x squared plus 5 squared has to be 13 squared. So x squared is going to be 13 squared is 169, 5 squared is 21. We are left with 144. So x has to be either plus or minus 12. Given that we are in the second quadrant, we know that x will be minus 12. Now we come and say that tangent of alpha is a ratio of y over x, and so that's going to be 5 over minus 12, better written as minus 512. Similarly, we are going to go after the other angle. Sine of beta is given to be minus 1213 and beta is in quadrant 4. Let's draw another picture. So we have some angle here. You can either go clockwise or counterclockwise, either way. So let's say beta. Some point on it we fix. Suppose its coordinates x and y. And distance from the origin is r. This is what y is and this is what x is. We are given that sine is minus 1213. So denominator, the radius always taken positive. Y, we write it in a different color. So r is 13. Y better be minus 12. Oh, so what about x? So this is 13 squared again is x squared plus minus 12 squared. So 169 is x squared plus 144, and x squared becomes 25, so x is plus or minus 5. Given that we are in the fourth quadrant, x has to be positive, so x turns out to be 5. X is plus 5. Well, what else do we need? We need the tangent of beta. Tangent of beta again is y over x. Y is minus 12, x is 5, and this is better written as minus 12 fifth. So we are going to substitute the values we have. Tangent of alpha, for this I'm going to have minus 512, minus tangent of beta, that is minus 12 fifth, over 1 plus tangent of alpha minus 512, tangent of beta is minus 12 fifth. Now we have to take a common denominator here. That's going to be 60, and the first one is going to be minus 25, and the second one is going to be 144. Denominator, these two fractions cancel each other out. We have 1 and 1 is going to be 2. If you don't mind me continuing here, I'll have 119 over 60 over 2, and I get 119 over 120. So other problems are similar to this. We have here another example. We are asked for sine of alpha plus beta, and we are given sine of alpha, sine of beta, and quadrants information. So so let's write sine of alpha plus beta. Remember that sine of alpha cosine of beta plus cosine of alpha sine of beta. So we want to get this information and put it here. I already know what sine of alpha is, so this much I know, minus 3/5, and I know sine of beta, I know that one is 4/5. I have to find out these two values and I'll be done. So let's go again, draw our picture, say for alpha. So this is for alpha. Alpha is in quadrant 3, so we just draw something in quadrant 3. This is angle alpha. What do we know about this is that sine of alpha is minus 3/5. So denominator in positive form, best left for the radius. This is r equal to 5. R equal to 5. Sine is a ratio of opposite to hypotenuse, so it has to be y is equal to minus 3 as the opposite of our angle. How about x? Well, by now you know this has to be the famous angle 345, except that we have to determine if it's a positive or negative. So given that we are in the third quadrant, so alpha is in the third quadrant, x has to be negative, so x is going to be a minus 4. How about what do we want from this situation? Well, we want cosine of we want the cosine of alpha. Cosine of alpha is a ratio of adjacent to hypotenuse. So it's going to be minus 4/5, and so I'll have this quantity here minus 4/5. Let's repeat the whole thing with respect to the other angle. For beta, we know we are in quadrant 2, so we are here. This is for picture for beta. We are in quadrant 2. This is some angle beta. Its sine is 4/5. So what does that mean? So R has to be 5. Opposite has to be 4. The adjacent, given that we are in second quadrant, will be minus 3. Is that right? So 4 and 5 came out of the fact that the sine of beta has to be 4/5. We are in the second quadrant, so the side here is going to be counted as x is minus 3. What do we want from beta? We want its cosine. What is cosine of beta? X over r. So minus sorry, minus 3/5. So this one is going to be minus 3/5. So product of these two is 9/25. Okay, 9/25 minus 16/25. So all boils down to minus 7/25. Let's try another example of this type. Tangent of alpha plus beta. Similar to the first one, tangent of alpha plus beta. Remember, this is tangent of the first plus tangent of the second over 1 minus tangent of the first, tangent of the second. I'll draw two pictures. For alpha in quadrant 4, we are somewhere here. This is the angle. If you want to go counterclockwise, characterized by minus 12/13. So minus 12 for the opposite, 13 for hypotenuse. We know triangle is 5, 12, 13. Is that right? Better to remember this thing. We have like 3, 4, 5 as one famous so-called Pythagorean triplet. We have another one, what's that, 5, 12, 13, and a whole set of them are out there. Makes a very interesting reading or a project for if you are interested. If you let me know. You can make a so-called tree out of these Pythagorean triplets, and a fascinating topic all by itself, but right now we are just using these well-known cases. So here x is 5. What do we want out of this thing? We want tangent. Tangent of alpha is going to be well, this is the point x, y. So it's 5 minus 12. Tangent, you remember, was y over x, and this one boils down to minus 12/5. How about a similar picture for beta? For beta, we have some new set of numbers. We have for beta, we are in quadrant 3. We are at some point where sine of beta is given to us as minus 8/17. That has to be 17. And this is going to be minus 8. So ratio of y to r, so sine of beta is y to r. So this is a point to coordinate x and y. R is hypotenuse 17. Well, how about we need x to calculate the tangent, and what do we have? We have x squared plus minus 8 squared is equal to 17 squared. So this more likely is going to come out to be one of those Pythagorean triplets I was showing you. One of those magical situations where the three sides of a right triangle turn out to be a whole number. 17 squared. So 17 squared. Okay, so x squared is going to be 17 squared minus 8 squared. So that is 289 minus 64 is 225. X will be plus or minus 15. And the x that works for us is minus 15. Why? Because we are in quadrant 3. So x is minus 15. What do we want? We want the tangent of beta, ratio of y to x. Y is minus 8, x is minus 15. So we simplify to 815. So we have two pieces of information. Tangent of alpha is minus 12/5. Tangent of beta is 8/15. And what is left is to plug these numbers in the fraction and see what we get. So tangent of alpha plus beta, that's going to be minus 12/5 plus 8/15. Denominator is going to be 1 minus that, makes it plus 12/5 times 8/15. So I take a common denominator. So I get minus 180 plus 40. I multiply by 75, both numerator and denominator. I get 75 plus 96. Just go ahead and do the arithmetic however you're comfortable with. Minus 140 over 171, if I'm not mistaken. So let me double check to see. So our final answer turns out to be this fraction. So in this lecture we combined the sum and difference identities with problems we had previously, information given about the ingredient angles, and we calculated whatever we needed from that given information. Quadrant was given and a trig value was given, so that would lead to all the other trig functions, and then we could find the sum or difference that we are after. Okay, so this was a combination practice problem. Probably going to have more of these things coming up. Until next time, good luck and God bless.